You know, there's a question that haunts me. It keeps me awake some nights, staring at the ceiling, my mind turning it over and over like a puzzle with pieces that don't quite fit. It's not a new question, it's been asked in various forms for decades, maybe centuries. But the more we learn about the universe, the more data we gather, the more exoplanets we discover, the more urgent and unsettling this question becomes. Where is everybody? Three simple words. A child's question, really. The kind of thing you might ask when you walk into an empty room expecting to find a party. But when you ask it about the universe, about the vast, ancient, star-filled cosmos, it becomes perhaps the most profound mystery in all of science. Let me tell you what I mean. Let me take you through the logic, the numbers, the implications, and let me show you why this question, this silence, this absence is so deeply, fundamentally strange. We'll start with what we know, then we'll move to what we expect, and then finally we'll confront what we actually observe, and the gap between expectation and observation. That gap is where the mystery lives. That's where the silence screams at us. Right now, as you're reading this, as you're lying there preparing for sleep, photons are hitting your retina. Some of them left their source a fraction of a second ago, the screen you're reading from, a lamp in your room. Others travelled much farther. Light from the sun takes about 8 minutes to reach Earth, so when you see sunlight, you're seeing the sun as it was 8 minutes ago. You're looking into the past. Light from the nearest star, Proxima Centauri, takes 4.24 years to reach us. When we observe it through a telescope, we're seeing it as it was over 4 years ago. If something dramatic happened there today, if the star exploded, if a planet was destroyed, if an advanced civilization turned on a beacon, we wouldn't know about it for another 4 years. The information, travelling at the fastest speed possible in the universe, would still be en route. Now, let's zoom out. The Milky Way, our home galaxy, contains somewhere between 100 and 400 billion stars. The estimates vary, but let's use 200 billion as a reasonable middle ground. 200 billion stars, each one a potential sun, each one potentially hosting planets. When I was young, when I was first falling in love with astronomy, we didn't know if other stars had planets. We assumed they probably did. There was no reason Earth's sun should be special, but we had no proof. We had no way to detect them. Planets are small. They don't emit their own light. Seeing a planet orbiting a distant star is like trying to spot a moth next to a lighthouse from 1,000 kilometers away. But in 1992, everything changed. Astronomers detected the first confirmed exoplanet, then another, then more. The discoveries started slowly, but as our detection methods improved, as we developed techniques like the transit method and radial velocity measurements, the floodgates opened. In 2009, NASA launched the Kepler Space Telescope with a single mission: stare at one patch of sky containing about 150,000 stars and watch for the tiny dimming that occurs when a planet passes in front of its star. The results were staggering. In its 9 years of operation, Kepler confirmed over 2,700 exoplanets. And here's what's crucial: it was only looking at a tiny fraction of the galaxy, one small patch of sky. When we extrapolate from Kepler's data to the entire galaxy, when we do the mathematics, we arrive at an astonishing conclusion. There are likely tens of billions of planets in the Milky Way alone, and a significant fraction of those, perhaps billions, are in what we call the habitable zone, the Goldilocks zone. Not too hot, not too cold. At a distance from their star where liquid water could exist on the surface. Let me pause here and let that sink in. Billions of potentially habitable planets in our galaxy alone. And the Milky Way is not special. It's one galaxy among hundreds of billions, possibly trillions, in the observable universe. The more we look, the more galaxies we find. Our current best estimate is around 2 trillion galaxies in the observable universe, each with its own hundreds of billions of stars, each with its own planets. The numbers become so large they lose meaning. Our brains didn't evolve to comprehend scales like this. But let's try anyway. If even a tiny fraction of planets, say 1 in a million, developed life, that would still mean millions of life-bearing worlds in our galaxy. If even a tiny fraction of those developed intelligent life, we're still talking about potentially thousands of civilizations, and that's just in the Milky Way, in just our galaxy. Now here's where it gets interesting. The universe is old, very old, 13.8 billion years old. Our sun, by comparison, is only about 4.6 billion years old. It's a relative newcomer. There are stars in our galaxy that are nearly as old as the universe itself. There are stars that formed when the universe was only a few 100 million years old, that have been shining for over 13 billion years. This means that life could have started on other planets billions of years before it started on Earth. Literally billions of years of head start. Life on Earth has existed for about 3.8 billion years, but for most of that time, it was single-celled. Complex multicellular life only arose about 600 million years ago. Humans, modern humans, have only existed for about 300,000 years. Civilization, agriculture, cities, writing, is only about 10,000 years old. Radio technology, which would allow us to send signals into space, is only about 130 years old. 130 years. That's nothing. That's a cosmic eye blink. And yet, in that absurdly short time, we've gone from the first radio transmission to space probes leaving the solar system, to rovers on Mars, to telescopes that can detect planets around distant stars. Now imagine a civilization that had a billion-year head start, or even a million years. What would they be capable of? What would their technology look like? We can barely imagine technology from 1,000 years in our own future. A million years? It's beyond comprehension. Such a civilization would be to us as we are to insects. No, even that comparison doesn't capture the gap. The technological and intellectual gulf would be so vast that we might not even recognize their artifacts as artificial. We might look right at their works and see only natural phenomena. This is the setup. This is the expectation. The universe is vast. It's old. It's full of planets. Many of those planets should be capable of supporting life. Life, once started, tends to persist and evolve. Intelligence has emerged at least once, here, in us. There's no reason to think we're unique or special. Therefore, we should expect the galaxy to be teeming with life. We should expect to see evidence of intelligence, evidence of technology, evidence of civilizations that have been around far longer than we have. But we don't. We see nothing. We detect nothing. The galaxy is silent. This is the Fermi Paradox, named after the physicist Enrico Fermi, who supposedly asked during a lunch conversation in 1950, "Where is everybody?" He was making a simple observation. If intelligent life is common, if civilizations arise with any regularity, where are the signs? Where are the radio signals? Where are the megastructures? Where are the star-spanning empires? The paradox is the gap between expectation and observation. We expect to see something, we see nothing. These two facts, the high probability of life and the complete absence of evidence, seem incompatible. And yet both appear to be true. Let me tell you about our search efforts, because it's important to understand that we haven't been sitting idle. We've been looking, actively looking, for over 60 years. SETI, the search for extraterrestrial intelligence, began in 1960 when astronomer Frank Drake used a radio telescope in West Virginia to listen to two nearby sun-like stars for any artificial signals. He found nothing, but it was a start, the beginning of a systematic search. Since then, SETI has expanded. Multiple projects, multiple telescopes, listening across different radio frequencies, looking at thousands of star systems. We're not just listening for deliberate messages, we're listening for anything artificial, leaked radio signals, the electromagnetic equivalent of the light pollution that spills off Earth into space. In 1977, a signal was detected by the Big Ear radio telescope that was so strong, so unusual, that the astronomer on duty wrote "Wow" in the margins of the computer printout. The WOW signal, as it's now known, lasted 72 seconds and has never been detected again despite numerous attempts to find it. We don't know what it was. Natural phenomenon? Artificial signal? We simply don't know. But here's the thing. Apart from that one ambiguous detection, we've found nothing. Decades of searching, thousands of stars examined, millions of radio frequencies monitored. Nothing. Complete silence. And it's not just radio. We're looking for other signs as well. Optical SETI looks for laser pulses, brief, intense flashes of light that would be unambiguous markers of technology. We're looking for technosignatures in the atmospheres of exoplanets, industrial pollutants, artificial chemicals that wouldn't occur naturally. We're even looking for megastructures, things like Dyson spheres, hypothetical constructs built around stars to capture their energy. In 2015, there was excitement about a star called KIC 8462852, better known as Tabby's star. Its brightness pattern was bizarre, irregular, unlike anything we'd seen before. Some scientists speculated it might be orbited by a megastructure, something artificial. Further observations suggested it was probably natural, maybe a swarm of comets or dust clouds, but the point is, we're looking. We're checking every anomaly, we're examining every strange signal, and we find nothing. Nothing artificial, nothing that can't be explained by natural processes. The silence is deafening. Now, before I go further, let me acknowledge something. The universe is vast, the galaxy is enormous. We've only been seriously searching for about 60 years, and we've only examined a tiny fraction of possible star systems. Maybe we just haven't looked in the right place yet. Maybe we're searching in the wrong way, looking for the wrong signs. This is possible. It's certainly possible that life is out there and we simply haven't detected it yet. The absence of evidence is not evidence of absence, as the saying goes. But the Fermi Paradox isn't really about whether we've detected alien signals. It's about something deeper. It's about the fact that, given the age and scale of the universe, even if intelligent life is rare, even if it only arises occasionally, we should still see evidence of it, because any sufficiently advanced civilization, given enough time, should be able to expand through the galaxy. Let me explain what I mean. Our galaxy is about 100,000 light years across. That's a vast distance, but given millions of years and technology even modestly more advanced than ours, a civilization could colonize the entire galaxy. Not necessarily with living beings, that might be too slow, too difficult, but with self-replicating probes. Von Neumann probes, they're called. Machines that travel to a star system, use local resources to build copies of themselves, then send those copies to other star systems. Exponential expansion. Computer simulations suggest that even travelling at a tiny fraction of the speed of light, say 1% of light speed, a civilization could spread probes throughout the entire galaxy in about 10 million years. 10 million years. That sounds like a long time, but in galactic terms it's nothing. It's a fraction of a percent of the galaxy's age. The Milky Way has been around for over 13 billion years. If an intelligent civilization arose even 1 billion years ago, they would have had more than enough time to spread across the entire galaxy many times over. We should see their probes. We should see their artifacts. We should see some evidence that they were here, or are here. But we don't. We see nothing. This is what makes the Fermi Paradox so troubling. It's not just that we haven't received a message, it's that the galaxy appears to be empty of intelligent life, despite having had billions of years for it to arise and spread. So what's going on? Why is the universe so quiet? There are many proposed solutions to the Fermi Paradox. Dozens, actually. Some are optimistic, some are pessimistic, some are disturbing. Let me walk you through the main categories of explanations, because understanding these possibilities is key to understanding our place in the cosmos. The first category of explanation says, they're out there, but we haven't detected them yet. Maybe civilizations are common, but they don't broadcast. Maybe they're listening rather than transmitting. Think about it. Would you want to announce your presence to unknown intelligences? Maybe there's a reason for caution. This leads to the dark forest hypothesis, which we'll come back to. Or maybe they're transmitting, but we're looking in the wrong way. We're listening for radio signals, but maybe advanced civilizations use something else entirely. Neutrino beams, gravitational wave modulation, some technology we haven't even thought of. We're like someone trying to receive an email by watching for smoke signals. Maybe civilizations are there, but short-lived. Maybe the window during which a civilization is technologically advanced enough to send signals, but hasn't yet destroyed itself, is very brief. A few hundred years, maybe 1,000. In a galaxy billions of years old, the chances of two civilizations existing at the same time and being able to communicate would be vanishingly small. Or maybe intelligence is out there, but it's so different from us that we don't recognize it. Maybe it doesn't think like we think. Maybe it doesn't build technology that looks like technology to us. Maybe we're looking for cities and radio signals, and they've transcended such crude methods. These explanations preserve the hope that we're not alone, that life and intelligence are out there, somewhere, and we just haven't found the right way to detect them yet. But there's a second category of explanations, darker explanations. These suggest that we're not alone, but that there's something preventing us from seeing others. One of the most chilling is the dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin. The idea is this: the universe is a dark forest. Every civilization is a hunter, creeping through the trees. Detection equals death. If you reveal your position, you might be destroyed by another civilization that sees you as a threat. The logic goes like this: resources are finite, the universe is competitive. If another civilization knows about you, they have three options: ignore you, communicate with you, or destroy you. Ignoring you is risky. You might become a threat later. Communication is risky. You don't know their intentions. The safest option, from their perspective, might be preemptive destruction. Therefore, every civilization should remain silent and hidden, and should destroy any civilization they detect before that civilization can threaten them. If this is true, if this is the nature of galactic civilization, then the silence makes perfect sense. Everyone is hiding, everyone is watching for others, and if anyone is detected, they're eliminated. The galaxy would be full of civilizations, but all of them silent, all of them hidden, all of them afraid. It's a paranoid vision, it's disturbing, and it might be correct. Another disturbing explanation is the zoo hypothesis. Perhaps they're out there, watching us, studying us, but deliberately not making contact. Like anthropologists observing an uncontacted tribe, or zookeepers watching animals in an enclosure. We're an exhibit, a nature preserve. They've declared Earth off limits, forbidden contact until we reach some threshold of development. This hypothesis is deeply unsettling because it makes us passive. We're not the seekers, we're the studied. We don't have agency in first contact. They do. And we'd have no way of knowing if it's true. The evidence for the zoo hypothesis and the evidence for being alone would look exactly the same. Silence. Or perhaps the planetarium hypothesis. Maybe what we see when we look at the universe isn't real. Maybe we're being shown a simulation, carefully curated to make us think we're alone. The night sky we observe is a projection, hiding the real galaxy teeming with life. This sounds like paranoid science fiction, but it's been seriously proposed by some scientists. If a sufficiently advanced civilization wanted to isolate us, to prevent us from knowing about galactic civilization, until we were ready, they could potentially manipulate what we observe. These explanations, dark forest, zoo, planetarium, all assume life is common but hidden from us for some reason. We're not alone, but we're isolated, quarantined, protected or threatened. Either way, the result is the same. We see nothing. But there's a third category of explanations, the most sobering category. These explanations suggest that intelligent technological life is rare, extraordinarily rare, possibly unique. This is where we encounter the concept of the Great Filter. The Great Filter is one of the most important concepts for understanding the Fermi Paradox, so let me explain it carefully. The idea, proposed by economist Robin Hanson, is this. Somewhere between lifeless matter and galaxy-spanning civilizations, there's a filter, a barrier, a step that's so difficult, so improbable, that almost no one gets past it. Think of it as a series of hurdles. Each one must be cleared to reach the next level. Start with a planet, add the right chemistry, add energy. Eventually you get simple life. Simple life has to become complex. Complex life has to become intelligent. Intelligence has to become technological. Technology has to become sustainable. And then, perhaps, civilization spreads to the stars. Each step has some probability of occurring. Multiply all those probabilities together and you get the chance that any given planet produces a star-faring civilization. If the result is a very small number, that would explain the silence. But where is the filter? Which step is the nearly impossible one? It could be early, it could be the origin of life itself. Maybe abiogenesis, the formation of living systems from non-living chemistry, is fantastically, incredibly rare. Maybe it requires such a specific set of conditions, such an unlikely series of molecular accidents, that it almost never happens. We don't know how life began on Earth. We have hypotheses, RNA world, metabolism first, hydrothermal vents, but we don't know. We've never observed life arising from non-life. We've never replicated it in a laboratory. If life is the filter, if life is the rare step, then we might be alone in the galaxy. But we've passed the filter, we're safe. The future is open. Or maybe life is easy, but complex life, eukaryotic life with nuclei and organelles, is hard. Life on Earth remains single-celled for about 2 billion years. 2 billion years. That's half the current age of the planet. Then, in what appears to be a singular event, one cell engulfed another, and instead of digesting it, kept it as an endosymbiont. The engulfed cell became the mitochondrion. This event, endosymbiosis, only seems to have happened once in Earth's history. Every complex organism, every plant, every animal, every fungus descends from that single merger. If that step is the filter, if endosymbiosis is extraordinarily unlikely, then the galaxy might be full of planets with bacterial life but virtually no complex organisms. Prokaryotic worlds, everywhere, but we're one of the very, very few that made the leap to complexity. Or maybe complex life is common enough, but intelligence is rare. Evolution doesn't inevitably lead to intelligence. Intelligence is metabolically expensive. Brains consume enormous amounts of energy. For most of Earth's history, for hundreds of millions of years of complex life, no species evolved anything resembling human-level intelligence. Dinosaurs ruled the Earth for over 160 million years and never developed technology. If a different asteroid impact hadn't occurred 66 million years ago, they might still be here, and we wouldn't be. Intelligence emerged in us perhaps partly by accident, a series of environmental pressures, climate changes, dietary shifts that selected for bigger brains and better social cooperation. It might be a fluke. It might be that most planets with complex life never evolve intelligent tool users. If that's the filter, the galaxy could be full of worlds with ecosystems as rich as Earth's, but empty of minds that can contemplate the stars. These early filters are frightening in their own way. They make us vanishingly rare, but they're not existential threats. If the filter is behind us, we've already passed the test. We're safe. But what if the filter is ahead of us? What if the step from intelligent life to long-lasting star-faring civilization is the nearly impossible one? This is the truly terrifying possibility, because we don't know if we can pass that filter. We don't know if any species can. Maybe every technological civilization destroys itself. Maybe there's something about achieving nuclear weapons, or biological engineering, or artificial intelligence, or ecological collapse that's universally fatal. Maybe the same intelligence and technology that could let a species spread to the stars also, inevitably, leads to self-destruction. Think about it. We've had nuclear weapons for less than 80 years, and we've come terrifyingly close to using them multiple times. The Cuban Missile Crisis, false alarms that nearly triggered launches. We've built enough weapons to destroy civilization many times over, and we still have them, thousands of them, aimed and ready. We're also currently conducting an uncontrolled experiment with our planet's climate. We're altering the chemical composition of the atmosphere faster than at any time in millions of years. We're causing a mass extinction event. We don't know if we can stop it or adapt quickly enough. We're developing artificial intelligence that might soon surpass us in capability. We don't know how to control it. We don't know how to ensure it remains aligned with human values. We're building something that could be our successor or our destroyer, and we're doing it without full understanding of what we're creating. We're editing genes. We're creating synthetic organisms. We're giving ourselves godlike powers over biology without necessarily having the wisdom to use those powers well. Any one of these could be a great filter. Anyone could be the reason civilizations don't last long enough to spread to the stars. They get to about our level of technology and then something happens. War, plague, environmental collapse, AI disaster, something. If this is true, if technological civilizations have a brief window before self-destruction, then the galaxy might be full of ruins. Dead worlds, archaeological sites, planets where intelligence arose, built cities, reached for the stars, and then fell silent. The universe would be a graveyard of failed civilizations, and we're just the latest species approaching the same cliff edge, and we wouldn't know. We wouldn't see evidence of those dead civilizations because they never lasted long enough to spread beyond their home worlds. Their radio signals would be brief, a few decades or centuries of broadcasts, then silence. By the time those signals cross interstellar space, the civilization that sent them would already be gone. This is the nightmare scenario. The filter is ahead, and we don't know how to pass it. We might be decades away from our own extinction event, or centuries if we're lucky, but the outcome is the same. We join the silence. We become another empty world in a galaxy of empty worlds. There's a version of this that's even darker. Maybe the filter isn't just self-destruction. Maybe it's something else, something we haven't thought of, something that happens to every civilization at about our stage of development, a cosmic disaster we can't predict or prevent. A phase transition in technology or society that's universally fatal. We wouldn't know what it is until it happens to us. I should pause here and acknowledge how I'm feeling as I write this, as I contemplate these possibilities, because it's not purely intellectual. There's an emotional weight to it, a sense of dread, but also wonder. Maybe sadness. The thought that we might be alone, or that we might be doomed, or that we might never know which is true. It's heavy. But let me offer you some other perspectives, some ways of thinking about the paradox that are less apocalyptic. Maybe the filter is real, but it's not absolute. Maybe some civilizations pass it, just very few. So few that the galaxy has only a handful of starfaring species, separated by vast distances and vast times. They exist, but they're so rare and so far apart that contact is effectively impossible. If there are, say, 10 successful civilizations in the entire galaxy at any given time, the average distance between them would be tens of thousands of light years. Even if they're broadcasting, even if they're looking for each other, the signals would take tens of thousands of years to cross the gap. By the time you receive a message and send a reply, the civilization that sent the original message might be extinct. Conversations would be impossible. You'd be talking to ghosts. Or maybe civilizations exist, but they're not interested in expanding. We assume that any intelligent species would want to explore, colonize, spread. But maybe that's a human assumption. Maybe most species, once they reach a certain level of development, turn inward rather than outward. Maybe they build virtual worlds and live in simulations. Maybe they transcend physical existence entirely, uploading themselves into some substrate we can't detect. Maybe they become something that doesn't leave physical traces, or maybe they're just not interested. Maybe the urge to explore and colonize is specific to young, aggressive species. Maybe mature civilizations find contentment on their home worlds. They stabilize their populations. They live in balance with their biospheres. They turn to art, philosophy, mathematics, experiences, not conquest and expansion. If this is true, the galaxy could have many civilizations, but they're all quiet. Not hiding exactly, just not bothering to announce themselves. Living peacefully on their own worlds, uninterested in the noise and drama of galactic empire building. Another possibility, maybe they've transcended us so completely that we don't recognize their presence. Arthur C. Clarke wrote that any sufficiently advanced technology is indistinguishable from magic, but we could take that further. Maybe sufficiently advanced technology is indistinguishable from nature. Maybe what we think are natural phenomena, pulsars, black holes, dark matter, dark energy, are actually artifacts of advanced civilizations. We look right at their technology and see only physics. We're like ants trying to understand a smartphone. We can observe it, measure some of its properties, but we have no framework for understanding what it is or what it does. Maybe the universe isn't empty. Maybe it's full of intelligence, and we're just too primitive to recognize it. Or here's a thought that I find both humbling and oddly comforting. Maybe we're early. The universe is 13.8 billion years old. That sounds ancient, but the universe will probably last for trillions of years. Maybe tens of trillions, or hundreds of trillions, depending on the physics of dark energy. Stars will keep forming for perhaps another 100 trillion years. From that perspective, 13.8 billion years is early. Very early. We're in the first tiny fraction of cosmic history. If you compressed the entire past and future of the universe into a single year, we're perhaps on January 2nd or 3rd. Almost everything is still to come. Planets around the earliest stars would have been inhospitable. The universe needed time to create heavy elements: carbon, oxygen, nitrogen, iron. These elements are made in stars and scattered by supernovae. The first generation of stars had almost no heavy elements. The second generation had some. Our sun is third or fourth generation. Earth is about 4.6 billion years old, but stars will keep forming planets for another 100 trillion years. Most planets that will ever exist haven't formed yet. Most potentially habitable worlds are still in the future. Maybe we're not late to a galactic party. Maybe we're early. Maybe we're among the first intelligent species to arise in this universe. Maybe in a few billion years, when we're long gone, the galaxy will be full of civilizations. But right now, in this early epoch, we're one of the first. If this is true, the silence makes perfect sense. We're not hearing anyone because there's no one to hear yet. The universe is still young. Intelligence is still rare because there hasn't been enough time for it to become common. This has a profound implication. If we're early, if we're among the first, then what we do matters. We might be the ancestors of galactic civilization. Our choices, our actions, whether we survive or destroy ourselves, this could determine the pattern for species that come after us. We could be the elder race, not the ones searching for ancient aliens, but the ancient aliens that future species will search for. That's a heavy responsibility, but also kind of beautiful. Let me tell you about a moment in history that might be relevant here. In 1977, NASA launched two spacecraft, Voyager 1 and Voyager 2. Their primary mission was to explore the outer solar system, Jupiter, Saturn, Uranus, Neptune, but both craft carried something extra: a golden record, a 12-inch gold-plated copper disc containing sounds and images from Earth. The contents were curated by a committee chaired by Carl Sagan, music from different cultures and eras, greetings in 55 languages, natural sounds, thunder, wind, birds, whales, images of humans, animals, landscapes, mathematics, DNA structure, even the electrical patterns of human brain waves. The Voyager spacecraft have now left the solar system. They're in interstellar space, travelling outward at about 17 kilometers per second. In about 40,000 years, Voyager 1 will pass within about 1.6 light years of a star called Gliese 445. If there's anyone there, if there's any intelligence orbiting that distant sun, they might find our little golden messenger. The chances are infinitesimally small, space is vast. The spacecraft are tiny. They'll likely drift through the void for millions or billions of years without encountering anything, but they're out there. They're our message in a bottle, thrown into the cosmic ocean. I think about those golden records sometimes, about what they represent. Hope, maybe, or defiance. The universe is silent, so we decided to break the silence ourselves. We sent our voice outward, our music, our greetings, even though we had no idea if anyone would ever hear them. That says something about us as a species. Despite the silence, despite the paradox, despite not knowing if anyone else is out there, we reached out anyway. We tried to make contact. And we're still trying. SETI continues. New searches are being designed. The James Webb Space Telescope is analysing the atmospheres of exoplanets, looking for biosignatures, oxygen, methane, other gases that might indicate life. Future missions will have even more sophisticated instruments. We're looking at the spectrum of light passing through distant atmospheres, searching for the chemical fingerprints of life. Or even better, technosignatures, artificial chemicals that wouldn't occur naturally, industrial pollutants, chlorofluorocarbons, signs of technology. If we found that, if we detected artificial chemicals in the atmosphere of a planet 50 light years away, it would change everything. We'd know we weren't alone. We'd know that at least one other species developed technology. We might not be able to communicate. 50 light years is too far for conversation, but we'd know. But what if we never find anything? What if we search for centuries, examining thousands of star systems, millions of planets, and we find nothing? No signals, no biosignatures, no evidence of technology, just silence, everywhere, always. What would that mean? How would that change us? I think it would be a kind of revelation, a dark revelation perhaps, but profound. We'd have to accept that we're alone, or if not alone, then isolated beyond any hope of contact. We'd have to accept that the universe, for all its vastness, is empty of voices. That consciousness, intelligence, the ability to ask questions about existence, these things are so rare that they might as well be unique. It would make us more precious. If we're the only minds in the galaxy, maybe the only minds in the observable universe, then we're not just important, we're everything. We're the universe's only way of knowing itself. We're the only witnesses to the cosmic beauty, the only beings capable of understanding physics, of appreciating mathematics, of creating art and music and meaning. If we destroy ourselves, we don't just lose one species among millions. We lose perhaps the only consciousness in existence. We silence the only voice in an infinite darkness. That's a heavy thought to carry, but also maybe a motivating one. If we're alone, we have to survive. We have to pass whatever filter lies ahead, because if we don't, the universe returns to being just matter and energy, following laws, creating patterns, but with no one to observe those patterns, no one to assign meaning, no one to care. Or maybe we'd find out we're not looking in the right place. Maybe life is common, but not where we expected. Not on planets like Earth, but somewhere else entirely. Maybe life exists in the subsurface oceans of ice moons like Europa or Enceladus. Maybe it drifts through the atmospheres of gas giants. Maybe it lives in the warm caves of Mars, far below the frozen surface. Maybe it's in forms we haven't imagined, silicon-based rather than carbon-based, existing at extremely high or low temperatures, metabolism based on chemistry we haven't considered. Maybe intelligence doesn't require neurons. Maybe it can emerge in other substrates, quantum systems, crystalline matrices, plasma structures in stars. Maybe we're looking for something that looks like us, and we're missing entirely different forms of consciousness that are all around us. There's a researcher named Stuart Kaufman who talks about the adjacent possible, the idea that innovation and evolution explore the space of what's nearly achievable, what's one step away from current reality, but there are forms of order and complexity that might exist in the distant possible, forms so different from what we know that we don't have the concepts to even imagine them. Maybe the galaxy is full of life and intelligence, just nothing we'd recognize as such. Or maybe the answer is simpler. Maybe we're asking the wrong question entirely. The Fermi Paradox assumes that if intelligent life exists, it would be detectable. It would build things, send signals, leave traces. But maybe that assumption is wrong. Maybe intelligence, past a certain point, doesn't express itself in ways we can detect. Think about our own trajectory. A few thousand years ago, we communicated with fire and smoke signals. 100 years ago, we filled the airwaves with radio. Now much of our communication is digital, encrypted, compressed, increasingly indistinguishable from random noise. Our signals are getting quieter, more efficient, harder to detect. In a few more decades, maybe all our communication will be on fiber optic cables or laser links, point to point, directed, nothing spilling out into space. We'd become radio silent not because we've destroyed ourselves, but because we've matured technologically. Our civilization would be harder to detect, not easier. Maybe every civilization goes through this. A brief window of a few decades or centuries where they're loud, broadcasting radio and television into space. Then they get quieter as their technology improves. They're still there, still communicating, but in ways that don't leak into the cosmos. If that's true, then the window for detecting other civilizations through their radio emissions is vanishingly small. You'd have to be looking at the right star system during the exact few centuries when they're technologically advanced enough to use radio, but haven't yet moved beyond it. The odds of that alignment are terrible. It would be like trying to meet someone by showing up at a random location at a random time and hoping they happen to be there at exactly the same moment. The probability is essentially zero. So maybe they're out there. Maybe civilizations are common, but they're quiet because noise is primitive. Silence is sophistication. Let me tell you something about the scale of time, because I think it's relevant to understanding why the paradox is so paradoxical. Humans have existed for about 300,000 years. Behaviorally modern humans, with language, art, symbolic thought, maybe 70,000 years. Civilization, about 10,000 years. Industrial technology, 250 years. Radio, 130 years. Space travel, 65 years. These are all tiny timescales compared to geological or astronomical time. If you compressed Earth's 4.6 billion year history into a single 24-hour day, humans would appear in the last minute before midnight. Civilization would be the last second. Radio technology would be a tiny fraction of that last second. Now imagine two civilizations arising in the galaxy. The probability that they exist at overlapping times is already small, but the probability that they're both in their radio loud phase at the same time, vanishingly small. If civilizations last 1 million years, which would be impressive, but are only radio loud for a few hundred years, then only 0.03% of their existence would be detectable through radio. If there are 1,000 civilizations in the galaxy, but they're scattered across billions of years, the chance that any of them overlap in their detectable phase is minuscule. Time, as much as space, might be the barrier. Not just where is everybody, but when is everybody. We might be living in the wrong era to hear from them, just as they might be living in the wrong era to hear from us. Somewhere, in the distant past or distant future, there might be civilizations looking out at the galaxy, listening to the cosmos, wondering why they hear nothing, asking the same questions we're asking now, feeling the same loneliness we feel. And none of us will ever know the others existed. I want to tell you about something called the Copernican principle, because it's relevant to how we think about ourselves in the universe. The principle is named after Nicolaus Copernicus, who in the 16th century proposed that Earth orbits the Sun, not the other way round. This was revolutionary not just scientifically, but philosophically. It removed Earth from the centre of the cosmos. It made us less special. The Copernican principle has been extended over the centuries to become a broader philosophical stance. We are not special. We don't occupy a privileged position in space or time. We're typical observers in a typical location. This principle has guided science brilliantly. It's helped us avoid anthropocentric thinking. It's kept us humble. But the Fermi Paradox challenges this principle. If we're typical, if Earth is typical, if our galaxy is typical, then where is everyone else? The universe should be full of civilizations at various stages of development. We should be ordinary members of a crowded galaxy, but we appear to be alone, or at least we observe a universe that looks as if we're alone. So either the Copernican principle is wrong, we are special, we are rare, we are unusual, or there's some other explanation for the silence. And both possibilities are deeply strange. If we're special, if Earth and humanity are truly rare in a way that matters, then we carry an enormous weight. We're not just another species on another planet. We're possibly the only consciousness in this region of space and time, the only witnesses, the only meaning makers. But if we're not special, if we're typical, then the silence suggests something ominous. It suggests that whatever is causing the silence, whatever filter or barrier or fate, applies universally. It will apply to us too. We're not exempt from the pattern, we're just at an earlier stage of experiencing it. Neither option is comforting in the traditional sense, but both, I think, are profound. Let me shift gears for a moment and talk about what we've learned from our own solar system, because it's relevant to the life question. We used to think life required very specific conditions, Earth-like planets in the habitable zone with liquid water on the surface, stable climates, protective magnetic fields, the Goldilocks conditions. But the more we explore our own solar system, the more we realize that life, or at least the conditions for life, might be more common than we thought. Europa, one of Jupiter's moons, has a subsurface ocean. We're fairly confident about this. The tidal forces from Jupiter's gravity create enough heat to keep water liquid beneath kilometers of ice. That ocean might be in contact with a rocky seafloor, creating conditions similar to Earth's hydrothermal vents, where life might have originated. Enceladus, a small moon of Saturn, also has a subsurface ocean. We know this because the Cassini spacecraft flew through plumes of water vapor erupting from cracks in Enceladus's ice. That water comes from a liquid ocean below, and it contains organic molecules. Complex chemistry is happening there, in the dark, beneath the ice, warmed by tidal heating. Titan, Saturn's largest moon, has lakes and seas on its surface. Not water, it's too cold for liquid water, but liquid methane and ethane. Titan has weather, seasons, a hydrological cycle, just with hydrocarbons instead of water. It has complex organic chemistry occurring in its atmosphere and on its surface. Could there be exotic forms of life using that chemistry? We don't know, but it's plausible enough that we're planning missions to find out. Even Mars, cold and dry and apparently dead on the surface, might harbour life in subsurface aquifers or caves. The Perseverance rover is collecting samples that might, just might, contain biosignatures from ancient Martian life, or possibly even dormant life that persists underground. The point is, our solar system, which we once thought had only one habitable world, might have half a dozen places where life could exist. Some form of life. Maybe not complex, maybe not intelligent, but life nonetheless. If our solar system is typical, that's a lot of potential habitats in the galaxy, trillions of possibilities. But here's the thing, if life is common, if it arises easily wherever conditions allow, then the great filter must be later. It must be the step from simple life to complex life, or from complex life to intelligence, or from intelligence to lasting technological civilization. And the more we learn about life's tenacity, the more we find it in extreme environments on Earth, in boiling acid, in frozen Antarctic lakes, kilometers underground, in radioactive waste. The more we think life itself might not be the rare step. Life seems robust once it starts. It adapts, it persists, which pushes the filter forward, toward us, toward the steps we haven't taken yet. This is why the Fermi Paradox isn't just an abstract puzzle. It's not just an interesting question for astronomers and philosophers. It's potentially a warning. The silence might be telling us something crucial about the universe and about our own future. It might be telling us that civilizations don't last, that something, war, environmental collapse, technological disaster, stops them before they spread to the stars. And we're approaching that threshold right now in our lifetimes. We have the technology to destroy ourselves. We've had it since 1945. We've built weapons that could end civilization, that could render Earth uninhabitable for complex life, and we've come close to using them, terrifyingly close. Multiple times, through accident, through miscommunication, through escalation that spiraled faster than anyone could control. We're also changing our planet's climate faster than at any time in human history. We're in the middle of a mass extinction event. Species are disappearing at rates 100 to 1,000 times higher than the background rate. We don't know if we can stop it. We don't know if the systems we depend on, agriculture, fisheries, fresh water, stable weather, will remain functional as the climate continues to change. We're developing artificial intelligence that might surpass human intelligence within decades. We don't know how to control it. We don't know how to ensure it remains aligned with human values. We're building something that could be our greatest tool or our final invention, and we're doing it without complete understanding of what we're creating. These aren't hypothetical dangers. These are real, present, ongoing challenges. And the Fermi Paradox suggests, doesn't prove, but suggests, that these challenges might be universal, that every technological species faces them, and that most, maybe all, fail to overcome them. The silence might be a warning. The universe might be quiet because it's full of dead worlds. Planets where intelligence arose, where civilizations flourished briefly and then collapsed or destroyed themselves before they could spread beyond their home systems. If that's true, if the great filter is ahead of us, then our survival is not guaranteed. It's not even probable. We're facing a test that most species fail, and we don't know if we have the wisdom to pass it. But, and this is important, we also don't know that we'll fail. The Fermi Paradox presents possibilities, not certainties. We're reasoning from incomplete data. We're extrapolating from a sample size of one, ourselves. We don't know what the filter is, where it is, or even if it exists. Maybe we'll surprise ourselves. Maybe humans, for all our flaws, have something that allows us to overcome the challenges ahead. Maybe our capacity for cooperation, for innovation, for adaptation will be enough. Maybe we'll be among the rare species that makes it through. That solves its existential problems. That builds a sustainable, long-lasting civilization. Maybe 1,000 years from now, we'll be out there, not just on Mars or the Moon, but throughout the solar system and beyond. Maybe we'll have learned to live in balance with our technology and our environment. Maybe we'll have become wise enough to wield the powers we've given ourselves. And maybe, just maybe, we'll meet others who've done the same. Other species that faced the filter and passed it. Other civilizations that learned wisdom before it was too late. That's the optimistic view. And it's possible. Nothing in the physics forbids it. The universe is not actively malicious. The barriers we face are ones we've created ourselves, which means they're ones we can overcome ourselves. But it will require choices. Hard choices. Sacrifices. Long-term thinking. Cooperation on a scale we've never achieved. It will require us to be better than we've been historically. To be wiser, more careful, more considerate of the future. The Fermi Paradox in this sense is a challenge. The universe is asking us a question. Can you make it? Can you pass the filter? Can you become a lasting civilization? We don't know the answer yet. We're in the middle of finding out. Let me talk about something else for a moment. Something that relates to the paradox but comes at it from a different angle. The concept of meaning. One of the arguments I sometimes hear is this. If we're alone, if the universe is empty of other intelligence, then everything we do is meaningless. We're just temporary patterns of matter on one small world, and when we're gone, when the sun eventually expands and engulfs Earth in about 5 billion years, nothing we did will matter. No one will remember us. No one will know we existed. Our art, our science, our struggles, our triumphs, all of it will be erased, as if we never were. This is a nihilistic view, and I understand the emotional appeal of it. The universe is vast and old and indifferent. We're tiny and brief. In cosmic terms, we're nothing. But I want to challenge that view. I want to suggest that meaning doesn't require an eternal audience. That consciousness and experience have intrinsic value, regardless of whether anyone else observes or remembers them. When you listen to music, does it matter that the sound waves will dissipate and be gone forever? Does it matter that in 1 billion years, no record of that music will exist? No. The experience of listening, the emotion it evokes, the beauty of the patterns, that's valuable in the moment. The meaning is in the experiencing, not in some permanent record. The same applies to existence as a whole. If we're the only consciousness in the universe, that doesn't make our experiences meaningless. If anything, it makes them more precious. We're the only ones having them. We're the only witnesses to the beauty of reality. The only beings capable of understanding physics, of appreciating art, of feeling love and wonder and curiosity. That's not nothing. That's extraordinary. And if we're not alone, if there are others out there somewhere, separated from us by distance or time but existing nonetheless, then we're part of something larger. We're members of a community we haven't met yet, can't communicate with yet, but that shares something fundamental with us, the experience of being conscious in a universe that mostly isn't. Either way, alone or not alone, we matter. Our experiences matter. The fact that we can ask these questions, that we can contemplate the cosmos and our place in it, that we can feel awe and wonder, that's meaningful in itself. Carl Sagan wrote about this beautifully. He talked about how we're made of star stuff, how the atoms in our bodies were forged in stellar furnaces, scattered by supernova explosions, gradually assembled into planets and eventually into living things. We are, literally, the universe made conscious. We are the way the cosmos knows itself. If we're alone, we're the universe's only self-awareness. If we're not alone, we're one of perhaps many. But in either case, we're participants in something profound. The universe has organized itself, through billions of years of evolution, into structures capable of contemplating the universe itself. That's remarkable. That's beautiful. And it doesn't require external validation to be meaningful. Now, I want to bring this back to you, to the person listening to this, lying in bed, preparing for sleep, because all of this, the Fermi Paradox, the search for extraterrestrial intelligence, the questions about filters and civilizations and cosmic loneliness, all of it connects to you personally in ways that might not be immediately obvious. You are conscious. Right now, in this moment, you're experiencing reality. You're hearing words, processing ideas, feeling emotions. You're aware of your own existence, and that awareness, that consciousness, is one of the deepest mysteries in science. We don't know how consciousness arises. We don't know why certain configurations of matter, like your brain, generate subjective experience. We can study the neuroscience. We can map the neurons and the synapses. We can watch the electrical patterns and the chemical signals, but we can't explain why any of that creates the feeling of being you. The quale of experience, the inner life. This is called the hard problem of consciousness, and it's genuinely hard. It might be the hardest problem in science. And it connects directly to the question of alien intelligence, because if we don't understand consciousness in ourselves, how would we recognize it in something fundamentally different? Maybe consciousness is common in the universe. Maybe it arises easily from complex information processing. Maybe every sufficiently sophisticated system, biological or otherwise, generates some form of awareness. Or maybe consciousness is rare. Maybe it requires very specific conditions. Maybe it's an emergent property that only occurs in certain types of neural architectures. Maybe it's connected to quantum effects in the brain, as some theorists suggest, which would make it dependent on precise physical conditions. We don't know, but what we do know is that you have it. You're conscious. You're experiencing this moment. And in all the vast universe, across trillions of planets and billions of years, that's special. That's rare, or at least unusual. That's worth contemplating. When you look up at the night sky, when you see the stars, those distant suns, each potentially orbited by worlds of their own. You're engaging in an act that might be unique in this region of space. You're a local pattern of matter that has organized itself to contemplate distant patterns of matter. You're the universe looking at itself across vast distances. If there are others out there doing the same thing, looking up at their own night skies, wondering if anyone else exists, then you're part of a community separated by unbridgeable distances, but united in wonder. And if there aren't others, if we're alone, then you're even more remarkable. You're part of the universe's only self-awareness, the only witness to cosmic beauty, the only meaning maker in an otherwise meaningless cosmos. Either way, your consciousness matters. Your experience matters. The fact that you can ask questions about the universe and your place in it, that's extraordinary. And here's something else to consider. The fact that you're here, now, conscious and aware, required an astonishing series of unlikely events. Your parents had to meet. Their parents had to meet. Going back through generations, an unbroken chain of successful reproduction stretching back millions of years. Any break in that chain, any ancestor who died before reproducing, any random event that prevented a meeting, and you wouldn't exist. But it goes deeper than that. Earth had to form in the right location around the sun. The moon had to form, probably from a giant impact, stabilizing Earth's rotation and creating tides. Jupiter had to exist, deflecting comets and asteroids that might have sterilized Earth. The sun had to be the right type of star, stable, long-lived, not too hot, not too cool. And deeper still, the universe had to have the right fundamental constants. If gravity was slightly stronger, stars would burn out too quickly for life to evolve. If the nuclear forces were slightly different, carbon might not form. If the cosmological constant were slightly larger, the universe would have expanded too fast for galaxies to form. The list of requirements goes on and on. Coincidences stacked on coincidences. Unlikely events following unlikely events. And the result is you. Conscious, aware, wondering about existence. Some people see this chain of improbabilities and conclude we're designed, that the universe was fine-tuned for life, for consciousness, for us. Others see it as selection bias. We observe a universe where these unlikely things happened because we couldn't exist in a universe where they didn't. I don't know which interpretation is correct. Maybe neither. Maybe both. But what I do know is that you're here. Against enormous odds, the universe has configured itself in such a way that you exist and are conscious and are having this experience right now. That's worth appreciating. That's worth protecting. And this brings me back, one final time, to the Fermi Paradox and what it might mean for us. The silence of the universe is telling us something, we're not sure what. It might be a warning about our future. It might be a statement about the rarity of consciousness. It might be revealing a cosmic truth we don't yet understand. But whatever the answer turns out to be, the question itself is valuable. The fact that we can ask it, that we can contemplate our place in the cosmos, that we can wonder about others and search for them and hope for contact. That's a beautiful expression of what it means to be human. We're a curious species. We're not content with our immediate surroundings. We want to know what's beyond, what's out there. Are we alone? What does it all mean? These questions have driven human progress for millennia. They've inspired art and philosophy and science. They've led us to build telescopes and spacecraft and theories of the cosmos. They've made us reach beyond ourselves, literally and figuratively. And even if we never find the answer, even if the universe remains silent forever, the search itself is worthwhile. The reaching is worthwhile. The wondering is worthwhile. Because we're not just passive observers of the universe. We're active participants in its unfolding story. We're the universe's way of understanding itself. And every question we ask, every search we conduct, every moment of wonder we experience, that's the universe becoming more aware, more conscious, more alive. So when you look up at the stars tonight, or tomorrow night, or any night, and you feel that sense of awe, that sense of mystery, that wondering if anyone else is looking back, Know that you're engaging in one of the most profound human activities. You're contemplating existence itself. You're asking the biggest questions. You're participating in the universe's grand project of self-understanding. And whether you get answers or not, whether we find others or remain alone, whether the silence continues or is eventually broken, the act of wondering, the act of searching, the act of caring about the answer, that matters. That's meaningful. That's what it means to be conscious in a vast, ancient, mysterious universe. Let me leave you with a final thought as you drift towards sleep. A thought about time and perspective and the privilege of this moment. The universe has been around for 13.8 billion years. Stars have formed and died. Galaxies have collided and merged. Planets have been created and destroyed. And through all of that, through all those billions of years of cosmic evolution, the universe was not aware of itself. It was magnificent, it was complex, it was full of beauty, but there was no one to observe it, no one to know it existed. Then, on at least one small planet orbiting an ordinary star in one arm of one galaxy, something remarkable happened. Matter organized itself into life. Life became complex. Complex life became conscious, and consciousness became curious. And now, for perhaps the first time in this region of space, the universe can know itself, can contemplate itself, can wonder about itself. You're part of that, right now, in this moment. You're one of the ways the universe experiences itself. Tomorrow, the sun will rise. Photons that left the sun's surface 8 minutes ago will stream across space and light up Earth. Some of them will hit your retina. Electrical signals will travel along your optic nerve, and you'll see. You'll be conscious of seeing. You'll experience the light. That simple act, seeing, being aware of seeing, is a small miracle in a universe that's mostly dark and unconscious. And tonight, as you sleep, as your consciousness fades into dreams and rest, the universe continues. Stars burn, planets orbit, galaxies drift. The cosmic dance continues, whether you're aware of it or not. But when you wake, when consciousness returns, you'll once again be a window through which the universe observes itself, a point of awareness in the vastness. That's special, that's precious. Whether we're alone or not, whether the silence continues or is eventually broken, whether we survive our challenges or fall silent ourselves, right now, in this moment, you're conscious, you're aware, you're part of the universe's grand mystery. So rest now. Let the questions fade. Let the vastness become distant and abstract. Let your mind settle into the quiet rhythms of sleep. The stars will still be there tomorrow. The galaxies will still be spinning. The universe will still be vast and ancient and full of mysteries. And you'll still be here, conscious, aware, wondering. That's enough. That's everything. The great silence of the universe, whatever it means, whatever it's telling us, is part of a larger pattern, a larger story, and you're a character in that story. A small character perhaps, brief and local, but a character nonetheless, a point of light in the cosmic darkness. Sleep well, fellow traveller. Sleep well, conscious being. Sleep well, child of the stars. The universe is silent, yes, but that silence is filled with possibility, with mystery, with wonder. And tomorrow when you wake, you'll still be part of that wonder. The search continues, the questions remain, and that's beautiful. Good night, rest peacefully. Dream of distant worlds, if you dream at all. And know that whether we're alone or surrounded by unseen others, whether the universe is empty or full, whether the silence is a warning or just a fact, you are here. You are conscious. You are aware. And that's a privilege beyond measure. Sleep now. The stars are watching. Or maybe they're not. Either way, you're home. You're safe. You're part of something vast and ancient and ongoing. And tomorrow the search continues. Tomorrow we keep looking. Tomorrow we keep wondering. But tonight rest. The universe can wait. The great silence can wait. Your questions can wait. For now, just be. Just exist. Just drift into the soft darkness of sleep. Good night, seeker of answers. Good night, contemplator of cosmos. Good night, brief pattern of consciousness in the infinite night. The universe holds you, the silence surrounds you, and somewhere, in all that vastness, perhaps someone else is wondering about you. Or perhaps not, but you wondered. And that's what matters. Sleep well,